Thanks for joining us. We are going to wait another minute to have let everyone else in the room. Okay, everyone, thanks for joining us and joining our webinar for a case for energy modeling. I'm Melissa Moranci, AI staff working on the 2030 commitment program. And I am going to turn it over to one of our 2030 co-chairs, Vanessa Hostick and Corey Duggan, to lead the session.
Yeah, thank you, Melissa. I am going to very awkwardly get my screen sorted now. Can you see the PowerPoint, Corey? Okay. It didn't put the lime green border, so I wasn't convinced.
Yep.
All right, well, thank you all for joining us today. Many of you were part of the By the Numbers presentation last week, and this is a follow-up to that. So thank you for joining us for another round. My name is Vanessa Hostick. I am the outgoing chair for the AIA 2030 Working Group this year. I am also a sustainable design leader and architect for HOK. HOK is an architecture interior design heavy firm with a little bit of engineering, so we're big E, little a. We do a very wide range of project types, but we're, very architecture focused. We do have internal engineering and modeling, but a lot of times we need to go to our consultants like Corey. Corey and I work together a lot. So Corey, if you want to introduce yourself.
Great. Thanks, Vanessa. Yeah, I'm Corey Duggan with TLC Engineering Solutions. I'm also a member of the AI 2030 Working Group and MEP 2040 liaison between those groups. And, TLC is a full service consulting engineering firm. And so, like Vanessa said, we do MEP consulting as well as commissioning, energy modeling, lead facilitation. So we get the opportunity to sort of, work together on some of those projects and collaborate.
There we go. Today, Corey and I are basically going to have a conversation we have a lot of the time, which is how does energy modeling fit into our workload and into our projects? And Corey is one of my favorite people to call with a very long list of questions, and he's very patient about that. So we're going to go through a lot of that. And in the course of today's slides and that conversation, we're going to talk a lot about what energy modeling really has to do with the 2030 commitments and kind of going forward in the future, what do we think its role is going to be? We're going to talk about how different firms approach energy modeling. I've got a range of teams and projects and different sizes, and they all use it a little differently. But I have this very internal one firm focus, whereas Corey works with a lot of different firms, so he can bring kind of that range of focuses to the table. We're going to talk about the benefits of energy modeling and how to talk about them and promote them, especially to clients, because that's one of the #1 comments we got last week was, we're not doing as much modeling because the client doesn't want to pay for it or doesn't see the value. So how do we explain that and pitch that back to them? We're going to talk a lot about that. And then the last one, which is actually going to be the first one in the slides, are the trends that we saw coming out of the 2022 report. What are we seeing around energy modeling that made us want to talk about this today? So a couple very quick slides on our current sort of context for this conversation. The built environment is largely considered responsible for about 40% of our global emissions. Out of that 40%, you've got 8 to 10% that's embodied carbon. That's your materials. We're not going to talk about that today. That's a totally separate presentation. We are really focused on operational carbon, which is based on your energy use. Right now, you're seeing about 10% of that in commercial buildings, and then almost 20% is coming out of residential. Not all bad news, though. In the last almost 20 years, we've added around 62.5 billion square feet, or 22% increase to our gross building stock nationally. In that time, we've actually reduced our national emissions related to operational carbon. How? Part of it is increasingly stringent codes. A little bit of it is just around general awareness. Now that people know what it is and that they need to reduce it, they're making an effort. But a lot of it's coming through third-party programs, be that certification or even commitments like 2030. So not all bad news. What we're doing is making a difference. It is reducing those emissions. But if we want to get all the way down to that carbon neutrality, what's the next step and how are we getting there? So 22 report came out. Hopefully you all looked at that last month. We had about a 48% overall EUI reduction. It's a little bit of a step back. We'll see that on the next slide. We had over 420 firms report. This is fantastic. We even have a few firms averaging that 80% reduction on all their projects. Very cool, very hard to do. But what we've seen overall is an increase in the number of firms reporting how much square footage is being reported. The downside is we slipped back just a little in our average reduction. And we're going to talk a little bit about why that is, but as we're seeing an increase in reported square footage, we're not seeing that same identical increase in our efficiencies. Largely because we've seen a big drop in energy modeling. In the last 3 years, we've seen a 15% drop in modeled square footage. We did a lot of Q&A in last week's asked, why is this happening? We're going to try to address a lot of those today. There's a number of reasons this could be happening, but it's not an isolated incident coming out of the pandemic. This is something being seen by a lot of different firms. The good news is nearly all firms reported at least one modeled project, so everybody's aware and has engaged it to a degree. It's just not prevalent, and we want to talk about what it takes to make it a prevalent part of your design practice. Anything you want to add here, Corey?
No, I don't think so. I think that one of the pieces that in seeing the data that we're sort of stagnating with that percent savings. And I think a lot of that is because we're seeing less projects modeled. So we're really getting that code equivalency average that's, not showing us those projects that really are employing energy modeling and allowing them to show those larger PEUI reductions. It's all kind of getting diluted by the code equivalency of not modeled projects.
Yeah, which here you can see that the code equivalency is rising. That's the good news. And that is coming from a lot of jurisdictions, cities, states, otherwise adopting those more stringent codes. So that's helping to pull up that bottom number. The challenge is the top number that even when we are modeling, we're seeing a little less savings. And there's probably a couple of reasons for that. In part, it's because a lot of people are just doing code equivalent models. You're not taking credit for everything you're doing on a project. You're just trying to get your permit, which is understandable. You want it clear, you want it quick, you want it concise, you want to get it, approved so you can get out and get on site. But there is value in taking credit for everything you're doing. So we're going to talk a little bit about that later. Part of it also is we've talked to a number of firms where they're modeling the same square footage of projects based on the staff they have. You've got 2 people, but you're doubling your portfolio size. Those 2 people can only do so much. And so you're seeing the same amount being modeled, the same commitment, but your portfolio's gotten bigger. So as that relationship, that percentage got smaller. And that is a very common theme. So we're going to talk about some ways to deal with that as well.
Yeah, I think what you said right on that I think a lot of those projects are focused on just showing that they're good enough, but not going through to really show how great they are, not putting in all the pieces that's just like, we're good enough to meet code, but, not going to that next step that's putting in every single ECM and piece to really show. And honestly, there's probably a lot of projects that are, quote, not modeled showing up as code equivalency. And if they were modeled and showed what their real performance was, that we would actually see significantly higher PEUI savings.
Yeah. All right, so let's walk this all the way back to square one here. When we're talking about an energy model, what all is included? Do you really put all of the rooms in a building into that energy model? Is everything there?
Yeah, I mean, we're gonna model the whole building. There's certainly some simplifications there that don't make a difference in between the overall energy consumption. And that's a big difference between doing a load calculation versus doing an energy model. For loads, you're gonna want to really focus in on what the loads are for every single one of those rooms. So you know how much air to put in there, how much heating and cooling is required. But for the energy model, we're really more concerned with the zones, right? So we may take a block of offices and combine those together because they have similar orientation and similar use types. And really, that doesn't make a difference because realistically, there may be one thermostat that feeds back to a VAV box there. So those sorts of simplifications allow us to, produce essentially the same results without having to model each individual room.
Yeah. So the general massing of the building goes in, the amount of glass we have, the type of glass or envelope we pick, that's all there.
Right. Yeah, absolutely. And that's really important, especially if you start to look at buildings with more thermal mass, making sure that you're not modeling something that's maybe the same equivalent U value, but is lightweight steel frame versus something that's got a significant amount of thermal mass. The load profiles and the energy consumption and how those impact system efficiencies can be significantly different.
Yeah. All right, big question. We have spent hundreds of hours getting this Revit model to LOD 300 so we can get our drawings out. And I send you the model, and instead of sending me my results tomorrow, you tell me you need 3 weeks. Why aren't you using my Revit model?
I don't want to say that the Revit model's not useful, but it has a limited use for building the energy model. And a lot of that goes down to that they're built with significantly different purposes, right?
Yeah.
So, you guys are trying to build something in the Revit model that can be built, and also that's going to look good on a 2D floor plan and then, be able to be detailed out. Whereas with the energy model, like I said, we don't necessarily need every single room. And so we just need those zones. And so a lot of times we can use pieces of them, but in some ways, the Revit model is much more detailed than what we need, and in other ways, less detailed, right? That the information about that buildup of the envelope, it may be in a detail, but it's not explicitly defined in the Revit model. So, there's a little bit of push and pull there between things that we're having to then go build up in more detail by hand in the energy model versus, taking and simplifying some things, like spaces that can go together, or perhaps not modeling every single window, but that, hey, all these windows are together, the average U value of this strip of windows is 0.4 or whatever. That we can make those sorts of simplifications to make models run faster, be able to produce faster results. But some of that requires some manual work. There is no easy button to just transform a Revit model to an energy model. I mean, I think we all wish there was, but that's just not the state of reality.
I think one of the most mind-blowing things when we open up side by side and show the team is, in our Revit models, we're really worried about thicknesses, getting our alignments correct. How does everything come together? Because we're worried about the physicality of the assembly. Whereas in an energy model, it is a paper-thin surface that has all the information built into an algorithm because it is a time-climate relationship based on kind of the relationship between spaces and zones and how one interacts with the other to get energy. All that is built into the mathematical calculation. Revit's not, it can do that, but that's not what we're modeling for. And I think that's always the hard thing to remember is even when I see that little thin surface, everything's built into the math. You don't need all 15 layers of my Revit model. It's also a little cleaner.
Yeah,
We
and
talk
that can
about
make things look a little weird sometimes because, like you said, it's like you may have a 6-inch slab thickness or an 8-inch slab thickness or something like that, but then in the energy model, it's infinitesimally thin, right? But we still make sure everything lines up. But it does, if you're looking for everything to be completely matchy, it may not be exactly the same there.
and it's not necessarily wrong because it's working
No,
on
and it doesn't have to be,
kind
right?
of a time. Yeah.
Yeah.
So let's talk about baselines and what we compare it to, because we've got an ASHRAE model for code or for lead, and we've got a couple of other building type specific things going on. And then we have 2030. And they all seem to be a little bit different, right?
Yeah, for sure. And it can be really confusing because you've got your IECC based in, section C407, standard reference building baseline. Then you've got your ASHRAE 90.1 ECB baseline, and then there's a PRM baseline, and that PRM baseline is further different now that we have to employ building performance factors from ECB. And beyond that, looking at our 2030 baseline and the goal to try to get to 80% reduction right now is another completely different baseline. So the 2030 baseline is based on the 2003 CBEX data, which is coming from the Zero tool, which is the old Energy Star baseline essentially. And that's surveys of real buildings. It's not some modeled, thing. And it is a data set based on different climate zones and building types. And, they do have it all segregated out like that, but that still you're talking about taking assumptions from a modeled building and comparing them to energy use for real buildings in the past that may have been built to code, built to an old code, or built to new code, right? So there's a lot of variations in that. And then trying to compare that to, okay, what is the basic amount that I need to get below to just get a permit, right? So then largely that's our ECB baselines or IECC section C407. And then, LEED, we're still looking at 90.1 2010. So your LEED savings for version 4 are going to be completely different from your 2030 baseline savings, from your code baseline savings. And I think the key there is to just make sure you're looking at the right ones for the right use, and not confusing the fact that if you're looking at your LEED percent savings doesn't mean you're still not doing better for your 2030 savings. You should be doing significantly better versus the 2030 baseline than you would be for the LEED baseline, and even for current codes, which I think most jurisdictions probably are on 2018 IECC, some moving to 21 now, but so really code is a more stringent baseline than all of the others currently.
Yeah, and I think a couple of the good summary takeaways from that, 'cause it's a lot of acronyms. The good news is we do not pay our consultants by the acronym. Otherwise, Corey would be making all sorts of money off of me unnecessarily.
That's right.
Don't have to pay them an acronym. The other one is your 2030 baseline should be different than your code baseline. And it will likely be much higher. And that's not a bad thing. And the reason we froze that baseline in time is we're always comparing back to the same starting line. Otherwise, everybody's starting at a different spot, and it's hard to know, somebody's 30% savings here, it doesn't match the one over there. We couldn't contextualize our data. So the reason those baselines are frozen from that old data set is we're working to zero off of the same starting line. And that's been really important for us. So don't override it with your LEED baseline. Don't override it with your code baseline. Those are important for getting your permit, but don't use those for 2030. That's kind of your takeaway here.
Yeah. I do know that, there's a couple project types that maybe that's not true, right? I know that you talked about issues with the healthcare baselines, and part of that's just, there's certain buildings that's a smaller data set, right? And I know I've heard, Michelle with VMDO has said that they always use their 2010 energy model baseline for dorms and housing, because they've seen some major discrepancies there. So there are a couple building types where it might make sense if you're seeing something weird. And a lot of that's just due to lack of data in that data set for that particular building type. But in general, you don't want to override it. Yeah.
Yeah, thanks for reminding me, especially with inpatient healthcare, those baselines predate the ASHRAE 170 requirements for ventilation. So if you are in an inpatient healthcare situation and your baseline looks low, you're probably right. That's one of the, few exceptions there. So good point.
Yeah. Yeah. And then labs, right? Because we recommend
Labs,
that you
yep.
go to the I2SL benchmarking, because again, there's very little numbers of labs in that 2003 data set. The I2SL, which is sort of the net or the green lab group, they have their own benchmarking tool that you can use to set your baseline there.
We'll get to that in about 5 slides, but
Early.
a little quick. Let's talk about who's modeling. You know, most of what we saw coming out of the 22 data set, since the 2020 data set, is we're seeing a lot of design engineer, which makes sense. They're working on the systems. It's the more complex part of the energy model. We ask you guys to run it. There's a little bit more feedback you can do immediately. I think that makes a lot of sense. Modeling consultants. We do that a lot as well, where the team might be moving just so fast, the design engineer either is struggling to staff, doesn't have the right expertise, or it just makes sense to bring in someone third party. That's a great option. The other one is there's a little bit of internal architectural modeling, and I will tell you all, don't be afraid to do some of your own early modeling. We'll talk later about the tools. That's okay. But we're seeing a big range. For those of you looking at 2020 going, what the heck is that unknown? We used to allow people to put will be modeled and not specify who is going to do it. And we took that away as an option in 2020. That's that funky light green bar at the top. So don't freak out. You see that? There was a program change in how we documented it. But the good news is a lot of us are relying on subject matter experts that are sitting in engineering firms, like Corey.
Yep. And sometimes we show up as design engineer and sometimes we show up as modeling consultant. So there's certainly some crossover between those groups of people.
All right, so let's talk a little bit about tools. Because 2030 commitment, we're very tool agnostic. There's a lot of great tools. You want to pick the one that fits your building type, your schedule and expertise, just the comfort level, because someone modeling outside their comfort level may not get good results. We do respect that. However, I have a question for all of you. What is other? Other's not a tool. New requirement for 23 reporting going forward. If you pick other, you will have to fill in the blank and tell us what it is. Part of this is because it came to our attention we were missing a couple of pieces of software that are really common. We've gone in and updated those. So you guys are going to see a few extra options this year when you go to report. There's a few international tools that we don't have. If we start seeing really prevalent international options, we will add them. We're just not sure what's going on there. So that's part of it. The other thing is other is actually an important field. This energy modeling tools, we do need to know what they are. The reason is this is part of a little known memorandum we have with the Department of Energy. This really helps them internally in their research and their work understand what the industry is using so they can help us be more efficient and work better. The other thing is it helps us with external partnerships. If we suddenly see a lot of usage in Cove and Safera and Autodesk Insight, we can approach those software companies about getting an API, extra training. Can you reach out? Can we partner and do something? It really helps us in external partnerships and bringing better, more applicable training to all of you. So we're not making you fill in the blank because we're mean, and I'm begging you, please don't put in something that just don't retype other, don't type rubber ducky, you know who you are. Please give us an idea of what it is so that we can update our stuff. It also helps us with training. If we see that, IES is a big use here, if we know that's really prevalent, we'll start pulling those up in a lot of our trainings so that it's side by side for you all to use. So it helps us also be really effective. So that's a change coming in this year. It's not meant to be a huge change. It will also be in bulk import. So those of you who do bulk import, please be aware of that. And that's kind of an explanation as to why that's happening and why it's important to us.
Inquiring minds want to know.
Very much so. But on the topic of tools, there are so many tools. And what you use really depends on the needs of your project at that time and the question. It's okay to engage in early modeling internally as an architect. We use Insight because we have a lot of Autodesk stuff and it's just part of our workflow. It's easier. We've been really happy. We've tested it against some of our larger, more advanced models. Like I will run an Insight model in early design, then I'll look at Corey's model in CDs, and they've been about 5% off. And I know people have done similar studies with Cove and Safera and been really happy. Now there's an exception if you're a high ventilation or complex building. Don't recommend it for hospitals. I don't recommend it for labs. Be very aware of your building types, guys. But use it comparatively. We've had a lot of luck with the Ladybug and Climate Studio tools. If you are in a Rhino workflow, it's great for comparative decisions. But I'm not going to take any of those models and try to go get a permit with them. As we move into DD and CDs, I'm really engaging my consultants, my engineers, and asking them to run a heavier model like Energy Plus, be it eQuest, be it IES, running that more advanced, more systems heavy models so we can understand those relationships. So don't be afraid to mix and match your tools with your design type in your cases. And talk to your engineers about what they're using. And there are so many more than what I've got on this chaotic slide. This was to show you just the huge range, and I couldn't fit them all on and make it legible. So if you don't see your software on here, it doesn't mean it's bad. It just means I ran out of room.
Yeah, and I think
And
the key is to use it as a comparative tool, right? That
yeah,
especially if you're early in design, there's so many unknowns anyways that you really want to look at EUIs as a range. And so I think it's more of a, is this better than that? Or looking
yeah.
at very specific questions, like you said, than, really trying to think that you're predicting what the energy use is going to be at the end of design.
A good example is that we had a large rec center. We had a 4-pack of basketball courts. And the question we had was, does it matter which side of the building that is on in our massing? And we ran 2 or 3 different options and we found, yeah, actually it did. It had a lot more impact than I thought it was going to. And those are the kind of questions we're asking ourselves. We're not necessarily going to model, do I think a heat shift chiller would be good on this lab building? Like, nah, I'm calling Corey.
Right, right. Yeah. Well, and I think you should think about too, if there's any of these tools that then have synergies with whatever tool that, whether it's internal, external, whoever is going to be taking that over, to run it through, DDs and CDs, that if there's something that you can share and, can you start with something like if you're running a modeling Cove tool, I know, what is it now? You can export, Energy Plus IDFs, some stuff like that. So, maybe there's something that's a starting point that way maybe there's a little more consistency as you transition.
Or even between engineers and consultants. I have a project right now where the engineer's doing their load calculations in Trace, and we're going to do modeling in IES, and we are taking those loads and using them to inform our model. So there's a
Right.
lot there that can be used as a very supportive relationship between all the parties, and it really helps our communication as well. We sit down, we meet regularly, we talk through those inputs and those assumptions, and it's actually improving the overall understanding of what is changing the building and what isn't.
Yeah, that's a really good point because if you've got the engineer using one set of assumptions for their sizing and then the person doing the energy modeling using a completely another set of assumptions, which probably the ones being used for loads are higher, probably the ones being used for the energy model are a little lower. And I think making sure that there's some consistency in those sizings because it informs your baseline. It can change things a lot. So communication and consistency, even if there's different tools, is really important.
All right, let's talk a little bit about timing of modeling. What we saw coming out of 22 is a lot of construction document and construction admin level models. Not uncommon. That's when you get that final permit model, you get that lead certification model, you go through that final design review. That's your big model milestone. But we're seeing very little early modeling, which is actually a little concerning because early modeling is when you can have the most cost neutral impact. It's where you can really influence the design process in ways that can be a little bit more effective than you would, say 50% CD and you discover you're not hitting your marks that you wanted to. You really want to model earlier for that.
Yeah, and I really hope that some of this is not that the SD modeling is not being done, but that just it's not being reported at every phase. Because I know that's something that a lot of us used to do, that we would just report, whatever the last phase that we modeled, whether that was, DDs, CDs, or what have you. And, especially with the newer DDx tool, that changed, encouraging everybody to make sure to report at each phase that you're doing modeling so that we can really see how that's happening. Because Vanessa is absolutely right. The most impactful time to do energy modeling is in the SD phase. If you're waiting till CDs to do it, you're really just doing an accounting process. You didn't do anything to make the design better.
So how do we know what models we're supposed to run and when to run them? Because Corey, I'll call you like mid-phase and go, hey, I need a model. And that's kind of the email you get, like, hey, can you start that model? How do we
Right.
know what we're supposed to be running and what I need to give you at each phase?
Yeah, and I mean that's something that's been confusing because there it is. That's everybody would kind of ask for something a little different. It's like, would you just do the thing, please? Like, what would you like? Like, what baseline do you want me to do? You need a baseline? Like, we need a little bit more clarity and some common language to work with. And so ASHRAE created standard 209, which is standard for using energy modeling as part of the design. And as part of that, they break modeling up into different cycles. That way it's, really clear that Vanessa can call me and be like, hey, can you do modeling cycles, 1, 3, and 4 before the DD deliverable? And then we have a standard set of language and scope that we both understand what the expectation and what's being delivered there. And so that's something that's really helpful. And this is a standard that is under constant refinement. So there will be an update, coming soon. But realistically, we're hoping that this is something that gets more adopted as part of the integrated process for lead, potentially as part of, code for some jurisdictions. The only modeling cycle that 209 says is mandatory is cycle 3 load reduction modeling, because really there again, it's that SD modeling where you have the ability to reduce the load, which reduces the first cost of systems and then their efficiency. So really the biggest impact there that we can use. So, and I think this is something we'll talk about a little bit further on about, how you can use this to scope out energy modeling as part of your contracts too.
And would it be fair to say that that number 3 model, that load reduction model, feeds really well into that life cycle costing analysis process that really helps you find those first and long-term cost savings? Is that kind of fair? Is that the right one?
Yeah, well, I mean, I think 3 and 4, right? Because, those are the 2 big pieces. And the key there being that you want to do 3 before you do 4, because you want to start out with the smallest possible HVAC systems, right? And so then you have those sets of options that you can feed into an LCCA.
Yeah. All right, let's spend just a couple minutes on benchmarking. When we start a project and I call you and go, hey, this is going to be our energy target, you don't just like throw yourself straight into a CD level model, right? Like what do you do? Where do we start?
Well, I mean, I think, there's a lot of benchmarking tools out there. You could start with Energy Star, you could start with Zero Tool, you could start with, if you're in a lab, the I2SL tool. ASHI has a database of benchmarking too. But I think looking at, what the expectation is, right? What's reasonable? What did you end up with on a similar project, right? That that, okay, we employed all of these ECMs and this was a pretty good project, but we think this time maybe we can do a little bit better than that. So starting with, whether you're looking at specific EUI targets or percent savings over that, I think, looking at building type in the same climate zone is a really good place to start. And of course, here we've got a shot of what it looks like doing the comparison in the DDx between, healthcare medical office and just what's the range of EUI for this building type and what's the average, what's the code equivalency.
Which, for those of you opening the DDX right now to see where this is, you can't get to it yet, but you will in a couple of weeks. So
sneak peek
preview. But I do think it's helpful, that context when you go in, it helps. It also helps when you get numbers back from the engineer, until you're a little more comfortable talking about EUIs, you'll get one and you'll go, I don't know what that means. Like, great, I have a 36 for my office. Is this good or is this bad? And this really helps give you that context that, well, 36 is really good. Or I had a team get one back once it was 360 and they were all excited. They got their numbers. They did it while I was on vacation. And I was like, it's what?
Yeah.
And we
No,
found out it was off.
You did
decimal.
bad.
It was a typo. It was a 36. But it helps to give you kind of a feel for where you are so that you can also communicate a little bit to your client with confidence. This has also been really helpful. I have a lot of projects in jurisdictions with performance ordinances where a year after we walk away from that building, that client's going to be held to something. And as they make decisions, I'm able to go through and get a look and a feel for what does this really mean? Where are we going to be? Should I be concerned? And be able to voice those a little more clearly to the client and chart them out for my visual clients that this is where you are and this is what this decision means. It helps us have a really good, robust conversation.
Yeah, and I think having that conversation is really important, especially for, healthcare and labs and some of those things that there may be parts that, the engineer has been working with the owner on that they know is going to drive up the energy use that makes it not just your typical like, hey, this is an office building, so I'm going to give you what our typical office building good EUI target is, and then they say, oh, well, actually, there's a data center in the basement, so it's like, okay, well, maybe we need to, talk about what that means and sort of negotiating the impact of that on our goals. The same for healthcare. If you have a large imaging department or some pieces like that, I think it definitely needs to be a conversation and understanding all the parts of the program that are going to go into what that potential target is.
Yeah. And speaking of benchmarking, we talked a little bit about I2SL. For those of you who've been around a while, this is Labs 21. Some of us struggle to move to the modern age. This is a fantastic benchmarking tool. This is real data that a number of our clients put into this system, and it is understanding lab types, the percent of your building that's lab, your climate, the fume hood number, and it is constantly evolving, and it is a fantastic resource. If you are in the S&T realm, R&D type design, uh, check this out, connect with your local chapters. They've got great support internally to their chapters. Take a
They
look
have a
at it.
lot of
It's
good
really, really helpful.
presentations too.
Oh, really good. If
Yeah,
you
they've
just
got,
like science, if you're a science nerd, go hang out with these guys. It's awesome.
yeah. So, and there's a link down there about how to get to the tool.
I don't know if you see my mouse, but it's down there.
Yep, I can see it.
All right. So I think one of the important things we have to talk about, Corey, is we don't just model for fun. We don't just model and hope the model speaks to us. This is not, we don't ask the brick what it's going to be. It's not the same situation here with the energy model. I don't open the energy model and ask it what it wants to be. You have to model with intentionality. And I think one of the most important conversations we have on our projects is we'll do an energy sort of kickoff charrette. You tell me all of the information you need from architecture. We identify the timeline you need to get it. And then we also identify all the energy conservation measures we want to do. And it helps because you and I have done this together a few times. We can kind of throw stuff out like, I think you can get lower lighting power density. Let's play with that and see what it does. Or let's look at this other system type because there's a lot of incentives for it right now. Let's just see what we can get with it. But I think it's important you identify those before you model, before you start talking about like renewables and electrification.
Yeah, absolutely. Energy models, are really good for answering questions. And so it's not just you want to go in there and, well, let's just run it and see what happens, right? Well, you need some, like you said, intentionality about, well, what are we going to do? And I think if you look at, in 209, running that simple box model to just see, okay, where is the energy being used? And as you can see here on the stacked bar at the bottom, that's okay. Well, if we see that there's a lot of heating energy, then maybe we need to focus our ECMs and what we're talking about on, okay, what's driving that heating energy? What sort of options can we employ to make that get smaller? Is there heat recovery available? And, like in this example, starting to use ground source heat pumps to be able to reduce, how much is used there. And like you said, that we don't want to just, start by throwing a bunch of stuff in there and then putting solar panels on it. We really want to go through and find ways to reduce the loads, employ efficient systems, and use heat recovery to sort of balance them.
Yeah. All right, let's talk about a few of these myths. It takes a lot of time to energy model. It takes too much time. So we're just going to energy model it once, right? Like it's so time consuming.
Right. Well, and I think that's the reasoning for the one and done CD model, right? Is we don't have to do this. It's never going to get done in time. So, why do we do this? And I think this goes back to what we were just talking about asking the model specific questions, right? That, if we're in SD for a project and we're looking at treatments for different patient rooms on a hospital and whether it's east facing or west facing or, what have you, that not trying to go through and build the entire hospital to look at this one piece, right? We can build a patient room module and run different options on that and provide information much quicker that is more in the scale of time that the architect is looking, right? Because if they're waiting on you to build the whole hospital for something, then they've moved on, right? And so I think you've got to make sure that you're doing something that is to answer a specific question, and the level of detail that is right for that part of design, right? You're at SD. There's so much that's, undecided. Why are you building the whole hospital that's based on a bunch of assumptions?
Yeah. I think the other thing there is one of the things we do internally is we do a lot of project planning and scheduling, and we have a special spreadsheet that identifies what we're doing each week. We've added send energy modeler information in that task sheet. So if you're pull planning, if you're doing lean, if you're doing any of those methods where you're planning it out, add it in there and give yourself 2 or 3 weeks. Like talk to the modder. How long do you need? The bigger and more complicated the project, the longer they need to give you good, accurate feedback. And we build it in, and it's funny because we'll all kind of forget about it. And we'll hit that team meeting and it'll be that week and it'll say send energy modeler information. Everybody kind of panics. We just start sending Corey like random emails. He translates, he gets us all on a call, sorts it out.
There you
But
go.
add it in, plan it. They are a part of the team. And even if they're not sitting there with you every single week, have them identify what point in time triggers that conversation with them. And if you add it in, then you're not worrying about, oh, or we go to permit tomorrow. I wonder if you can get my model done overnight. Like, no,
Yeah.
don't call me. Yeah.
Well,
So
and I think being specific about what you're asking for, right? Back to the 209 thing, that's not just do the energy model, but that, hey, we're designing this right now. Could you give me feedback on, the shades on the east facade, right? That because then otherwise I may just work on the whole thing and be like, well, this is what I think the UI is, and then you're like, that's not what I needed,
yeah.
So I think again, it's about communication and, like you said, planning it into the process.
Another one we talk about a lot is it requires a lot of resources. It requires staff and time and fee, and there's a lot of review that goes into doing this model. And I have internal engineers. I have a fantastic modeler, Brian, but I've got like a Brian and it's a person that helps them. Sometimes it's overwhelming because we have 4 big projects on identical timelines. What am I supposed to do? Pick my favorite? That seems kind of dangerous.
Yeah, I mean, I think there's a couple different ways you can tackle it. One, you can consider bringing in another consultant, to add time, but of course that costs money. It may not be something that was planned out there, but if it's a project that's that large that requires that many people, I would think that, it could support something like that. But also that if you're saying that it's too much or too expensive or what have you, then, what is the what you've lost there, right? If it's a project that's that large and that these goals are that important, is that not something that should be considered as part of the design process? That you need that feedback about, how are these decisions going to affect the energy performance or the daylight? And there's also the ability that you can look at and say, okay, if I'm doing 5 office buildings that are on a campus and 2 of them are oriented the same, maybe I just need to do 2 of them, right? Because there's 2 unique shapes that have similar, usage profiles and similar orientation. So, make smart decisions and try to learn from experience. If, you just did another hospital patient tower that's, in the same climate zone, the same orientation, well, for a hospital, even if it's not in the same climate zone, there's a lot of lessons learned there that you could see that you can carry over. And so, making sure you learn from your last project, and you can apply those, maybe one where you did have a lot more energy modeling or more schedule, and you can use that to make good decisions on this project.
Yeah. Okay, for the sake of time, I'm going to bundle this last bit here all together. I get one a lot where teams go, no, not yet. My design's going to change. And I'm like, I hope so. We're going to model it and I want it to inform that change. It's okay that your model doesn't match that final SD or DD deliverable. What we want to do is time it so it's informing important decisions. We want that to be informed design. But the other one we get a lot is it's just code minimum. The client doesn't want to spend the money. We don't have the fee. Like I'm not going to model. It's just cheaper and easier to do comm check. And Corey, we've both talked about it. Can you really afford to not do the model, especially in some of these really aggressive jurisdictions?
Right. Yeah, that's a great point, because code minimum is code minimum for a reason. It's a very good starting point, but it's not perfect for all buildings in all climate zones. If you've got a high-rise building, so there's only one level under roof, then why are you spending all that money on extra roof insulation when it affects one floor? Or maybe the top floor is a penthouse, right? So if you were doing the energy model to look at the impact of each of those pieces, whether it's the amount of wall insulation, or do you use all continuous versus using batt? Can you make, the thickness of the wall smaller? Doing those sort of comparisons for trade-off against one another, you a lot of times can find a better set of options that may actually cost less to build for the owner and be more efficient at the same time, than what the code prescriptives are.
Well, one of my favorite stories, and not all are this successful, but we had a project we did, corn shell, and in one of our design meetings, the engineer laughed at us and he goes, well, if the architect would take 5% of their glass away, I could drop a whole chiller and the whole project would be back in budget. And we all sat up and went, no, no, we can do that. Where do we take it out? And we went through and marked up and ran about 3 iterations. We pulled it out and we got to drop one of our 2 chillers because we were only borderline really needing that second chiller. And there was so much first cost savings in that process just by going through that exercise. Don't discount that conversation that can happen and the amount of value add that is present. So
Absolutely.
much so that, we went through a couple years ago for an AIA presentation and talked about what did it cost to do one of our projects together and how quickly did that pay for itself in operational savings? And with the exception of just one of these, they were all within, a couple months, 3 months. Now that one at the bottom with the 7 months, we did models I didn't know existed on that job. We modeled stuff I didn't know could be modeled. That one was crazy with some of the stuff they wanted to look at, to study, the net zero stuff, the alternative fuels, alternative systems, super informative. But that one was maybe a little bit less typical than what I would say the rest of these were very typical projects.
Yeah.
So, there is a lot of value there, and those models do pay for themselves very quickly.
The point is, we're talking about months, not years.
Yeah.
So, I mean, in any other scope of time, we would say this is nearly instant, right? So the value of what you can achieve with the energy model is so much more than the time.
So to go over some of our key pieces here, we're going to summarize it. The last bit we're going to talk about is a little bit more project management, project input, and we've only got about 15 minutes here, so I want to get through these last few slides quickly, which we put them in the back in case we didn't get to them. Some of the keys for improving efficiency. Do model early, model often. That's how you find your cost-effective efficiencies. All of our high-performing projects started that early model and used that feedback to improve their designs. Don't be afraid of internal modeling. I know it's a hard thing to break into. Model and verify with your engineers models at first so that you get that comfort level, you see the differences, but it does make a big difference on some of those bigger, especially those faster projects where maybe you can't get an SD model done in the 2 to 3 weeks you have after award. We get that, we see that too. We're definitely talking about an ideal process. I will admit this does not happen on all of our jobs. I'd like it to, but reality is that's really hard. Ensure you're getting credit for your modeling. I always look at the model reports. We try to meet with the teams as soon as a model's done and we go through and make sure the assumptions match, especially around our glazing and our curtain walls. Corey and I spend a lot of time chatting, what type of glass did you pick this up? Did you pick this assembly? Is this really what we've got in the model? Or he'll call me and go, I see this in the Revit model. Is that right? You're not doing that. I'm like, oh no, we're not doing that. We haven't updated it yet. So there's a lot of conversation that goes back and forth there. Do use 209 for modeling scopes. I'm going to talk about contracts here in a minute. Electrification. Corey, I was surprised you ran one for me the other day. Electrification does not automatically mean more efficient, does it?
No, not at all. And I think that that's something that sort of, there's so much pressure to just like be very myopic about it. This is what we have to do every time. And I think that, depending on where you're at in the country, and looking at your different system types, that, it can be important to maybe create a plan to go to fully electric, as emissions from the grid reduce, or there's more, availability of, renewable electricity on the various parts of the grid. But, there are certain parts of the country where the grid is still, very dirty, and that using more of that electricity can actually be, worse than using a boiler on site. And also thinking about, some of the technologies that may require larger amounts of refrigerant, that those refrigerant fugitive emissions, you may be getting all electric heating and it may be more efficient, but whenever you put it all together in certain parts of the country, it actually may be more emissions than if you were to just put a boiler in. So I think it's important to look at sort of a total carbon perspective for it, and making sure that there's a plan to move to utilizing that renewable electricity as it becomes available.
And I want you guys to take away the message isn't electrification is bad or not justified. I think it's the warning of don't be surprised when it doesn't automatically look better.
Right.
Um,
There's a lot of places it's going to cost more
yeah.
right now still.
And it's the way we need to go, and it's the way the codes are moving, but you need to be prepared for that. And that doubles down on the model early and know what's going to happen when you switch to that.
Yeah.
Prepare for your project type. You're going to have a little more trouble if you need a lot of hot water. So just watch that, model for that, and don't be surprised by that. And look at your renewable integration to help offset some of that if carbon goals are the particular focus of that.
Yeah, because
Or
I know
even
we've
looking
had
at your stretch codes. Yeah.
where some owners have started out going, we're absolutely doing all electric, and then we run our energy models and show them the difference, and they'll say, these are your options, and they're like, oh, why does this cost more? I thought this was supposed to be, and it's like, well, not right now, not with your gas is so cheap. But I think that's where you can't just look at costs. You do need to look at total emissions, to where you're bringing in the fuel mix from your grid. If you have on-site renewables as part of the project, what are the fugitive emissions associated with the refrigerants? Is it greater or less with this type of system type going fully electric? So it's important to have a holistic picture in making informed decisions.
Yeah. All right, we're going to pop through a couple of these. As you guys look at maybe methodologies for getting closer to that emissions, lowering your emissions at net zero, if you don't have a particular structured approach, take a look at some of those stretch codes, those zero codes, like the IECC 2021 appendix for that. That will help give you structure to that conversation, even if you're not trying to follow it for your jurisdiction. We've talked a little bit about why we don't just use a Revit model. You can't get to your 80 or 100% reduction without that model. The one I want to hit on last, and then we'll go to questions, is I got this one the other day. I don't like modeling. It creates a lot of liability. And that one surprised me a little bit. They go, what if we're wrong? They go, well, you're going into a performance ordinance jurisdiction. We need to know, the client needs to know what decisions they're making. A code minimum building may not meet the performance ordinance for the district they're in. We need to model it. They go, but what if we're wrong? So one thing I'd encourage you all to go do is I had the fortune of presenting at AIA this last spring with Donovan and Annika. So Donovan is one of our legal counsel at HOK, and Annika's our director of sustainability. And we talked about how do you structure this to protect everyone involved. We follow the 209 standards, and we have added that to our contracts. So HOK has a special modeling contract we use because we see so much of it. So when I call Corey, this is the little form he gets, we fill it out. This is how we move forward. We review this with a client so they understand the assumptions, and that 209 helps outline what assumptions are required at which phase and allows us to document that in a way that we're all protected and we move forward with a lot of confidence. If you're using general AIA documents, you would be making a modification to your D503. So take that, add it as a chart, and use that as a reference appendix document that you can then attach with it. It is very, very helpful and helps alleviate some of those concerns. Bigger, so you can see that for those of you who like to screenshot as we go. It's very helpful.
Menu of standard 209 cycles.
Yeah, that's it. And then in addition to that, we have the outline, which is just, a lot of this is coming straight out of 209, which is kind of a verbatim summary. What happens in that first meeting that we do all together, we solidify those assumptions. Those minutes are everyone's sign off. So for those of you who have that fear, that concern around that, that is the best way to go about that. I'm actually going to skip ahead because our next bit was how do you report something to the DDx? And I know Melissa has a DDx call coming up to talk about adding in your values, doing it by fuel sources, what are the differences in the language. Fun fact, you can just add your consultant and I can make Corey report the projects he's modeling. It's great. He can only see those models I've added him to in my portfolio. Super handy feature. After that, reach out when you guys have questions. We're here to help. There's about, 12, 15 of us that meet regularly to talk about this stuff and to create these resources. And
if you
coming
choose
up,
other, you have to tell us what it is.
that too. And coming up, there's some other stuff about firm culture. How do you work 2030 into your firm identity? And then DDx updates. There are new features and we're really excited they're releasing soon. So join us in December to talk about what those look like.
Yeah, there may be a little sneak peek sprinkled throughout this presentation that you want.
Possibly worked ahead of the next presentation. All right, there's some really interesting Q&A in here, Corey.
Uh-oh.
And you guys, if you want to copy and paste your stuff into the proper Q&A, that will allow us to print out a record of this afterwards. If we don't get to your question, we can then send it to you as a follow-up email next week. But if it's in the chat, I lose it the minute this thing ends. So we're going to try to copy and paste as many as we can before we kill the session, but
Why
keep
don't we
that in
start
mind.
with the top one? Do you see the need to calculate linear thermal bridges on large commercial energy models to get an accurate PUI as they do on small residential projects in the passive house community?
Yeah, I mean, thermal bridges can make a big difference, especially if we're looking at in colder climate zones, because while they do make a difference in, you know, your climate zones 1, 2, and 3, because the delta T is so much smaller, you're not going to see as much of the conductive differences there. I would steer you towards what is in the new version of ASHRAE 90.1 2021, where they actually have factors and requirements for the adjustments of U values to account for thermal bridging. So that's how I would start to look at making sure to incorporate that. You know, balconies and the lot, those are just, you know, like fins on the building. So there's certainly going to be, you know, impacts on the energy use.
Yeah, and that's pretty similar to how we handled. If we know there's a lot of thermal bridging, we'll do a U value adjustment on the wall to make sure it's accurate.
Yeah, and I mean, I think those factors are good starting points, trying to make it approachable for everybody. You know, you can also do a therm model to kind of get an idea of what that U value adjustment should be.
All right, next question. Any recommendations on getting our design engineers to provide early and fast energy modeling results for the earliest analysis when we are evaluating massing, site layout, general wall to window ratios, and other really early analysis when lots of assumptions need to be made? Most of my partners use IES, and it seems like they aren't comfortable creating or providing comparative results without building a footprint, floor plans, and program.
Yeah, I mean, I think, again, you have to think about the level of detail that you're modeling for that part of the design process. So I think being very specific about what you're looking for feedback on, and that I think some folks get to where they feel like that the architects aren't going to, you know, sort of believe the results they're giving them if they don't make it look exactly like the picture they were given. But when you're trying to look at basic, you know, shapes and concepts and massings, window to wall ratios, doing just a simple box model with core and shell zoning, you can absolutely get that, you know, is this better than this feedback. And I think that's where you just need to make sure they're clear and that, hey, I'm not going to hold you to these absolute EUIs because we're making a lot of broad assumptions for the purposes of comparison of some big picture items. And so I think if you can sort of whittle that down, then they'll feel a little more comfortable and know what they need to provide you.
Yeah, we try to send a very specific list of items we want studied, like 50 and 60% window to wall ratio, because we know that's roughly where we're going to be. And certain sensitivity types, like we'll give them option 1, 2, and 3 for a specific item. Imagine if someone, like your client, called you and said, I need a conference room and I need the layout tomorrow, and then hung up the phone. And you're like, yeah, okay, I can do that. And you're like, wait, how many people? What are we gonna do with it? What kind of IT do they need? Is there gonna be a screen? How many screens? Do they need a big table? And you have all these questions you suddenly realize you need answered because you're not even sure where to start to give them options. I think our energy modelers sometimes have that reaction because they haven't seen the project very much. And if they haven't worked with a designer a lot of times, they're not sure what range of things to run as options for them. So we have to tell them, you know, I want 60 and 80% window to wall ratio because this guy likes glass. And, you know, we got to run through those options. So the other thing I would say is consider a standard list of options you like to run for project types and start with those every time, or a modification of those. And that's helped us when we're moving really fast internally. If someone pulls my standard sheet down, makes modifications, and kicks it back out, it took 10 minutes.
Yeah.
That's been really helpful.
I think the more you work with the same people and build a rapport and a relationship there, and you know what those expectations are, it's like you say, you know what Vanessa's typical go-tos are. That's like, all right, this is for so and so, you know, we're gonna have to look at this, this, and that.
Yeah.
So I think that helps you to sort of build some momentum, especially for projects that are moving quickly.
So technically we are at time. Do we want to export the rest of these questions and answer them via email and send it to you all after?
We
Does
can.
that work?
I'm going to copy and
Yeah.
paste a couple of the big ones that I think are super useful. Somebody asked about understanding what square footage is to model, and that is definitely a constant discussion. Do you include the parking garage? No, the answer is no. But I get that question all the time. Like, it's under my building. What do I do with it? It uses energy, it has lights, but it's not conditioned. So yeah, we'll pull a few of these over. I think they're helpful to understanding what to expect on a few of those different levels. Unless anyone has a really burning question they want to hit. Melissa, how are we going to get the questions back out to people? Just a mass email of all questions and answers?
Yeah, we need to email them after the session is over anyway. So,
Okay, perfect.
all right. Well, thank you all for attending. Thank you, Vanessa and Corey, for hosting. And I dropped in the chat our email. If you have any additional questions, email 2030commitment@aia.org.
Yeah, thank you all.
Thanks, everybody.